Now that we have learned a lot about graphing, we should know that there is a symmetry in graphing too as well. So what is symmetry in graphing? We should learn that before we do any symmetry or any related stuff to the symmetry on the graph. You see, it's better to understand the concept before you actually solve the problems, okay? Because when you solve this problem, you just have an idea on how to solve it, but you don't know the idea on how to apply them to the real life, okay? So here's how the symmetry, the definition of symmetry is. It's a quality of graph because it's a quality, alright, which makes the graph look alike. For example, let me give you guys an example. If you have the plain paper like this, and if you see that this is y-axis here, and this is x-axis here, you see, if this were a graph, and if you fold it downwards, like from up and you fold it like up from down, right, and it's equal. You see, it's equal, so it's a symmetry, okay? So what type of symmetry is it? It's x-axis symmetry, okay? Now, what is y-axis symmetry and what is x-axis symmetry? It turns out that when you fold like this to this, which is up, from up to down, it's x-axis, because x-axis lie as a horizontal. It's horizontal symmetry. Thus it's called, or it's called x-axis, because the x-axis is the horizontal line, you see. Now, if you have a y-axis standing right here, like over here, and if you were to fold it, you see it's equal. Now what type of symmetry is that? It turns out that the y-axis is also called vertical, right? Vertical distance, okay? Vertical line, okay? So if you were to flip it like this, it's y-axis, it's vertical line symmetry. See, vertical line symmetry and symmetry has a lot of things in common. Now, let's go ahead, take these examples and see the examples for y-axis first. Now that we have completely understood the concept of symmetry. So, if you were to have a graph right here, okay, and I'm not going to give you example which is also y-axis and also x-axis, okay. So here we have y-axis symmetry first, y-axis, okay. If you were to have let's say like that, okay, you would have something like that, okay. You see this point here lies this point over here. Think this point as a kid. If you were standing, like when there's y-axis symmetry or x-axis symmetry, it's completely easy if you understand. If you were, like, if this boy were on a beach, okay, and this is water, he sees his reflection, right? Like that. See, either we can make this as y-axis if the x-axis was lying over here, or you can make this as x-axis if this was lying over here. You see, this type of examples relate to all type of relationships, okay. Now I want you guys to see exactly what I was talking about in this example. Is, you see, if you understand this concept, you would understand other concepts too. So I want you guys to understand this concept first, so you can understand other concepts second. So, okay, so if this were some kind, if some value x and y, okay, let me just erase it and write in different colors so you exactly know what am I doing. So suppose if this point right here was some value of x and some value of y, right? You know, it's, if this is quadrant 1, right? So it's both positive. We can't say it's negative x comma negative y. Both are positive in quadrant 1. So some value of x and some value of y. And if we were to take this kid and reflect it, and this was line of reflection, which is y-axis, as shown here, this would point over here, which turns out that this is negative side, so it's negative x, and it's all as positive as upwards, so it's y. So x and y, when reflected onto the quadrant 2, on symmetry, if it had a symmetry on quadrant 2, and it's symmetry from y-axis, it turns out that x and y value comes over here, and it becomes negative x and y. Okay, now that we have learned y-axis symmetry and a little example of x-axis, which I showed you as a boy, reflecting his own body in the pool or beach. Reflection is, you can think of in daily life, when you walk in the path, you see your shadow. That is also called a reflection. Okay, so let's take an example of x-axis symmetry. So, as you guys should know, that this is x-axis and this is y-axis. Now we are going to look at the symmetry of x-axis. So the best example for symmetry of x-axis would be something like this. You see, this, if this were to touch this point, it would become a circle, but it doesn't. Okay, in this case. So this symmetry is actually x-axis symmetry. Now let's say the point was here, because you're reflecting it up from down, right? From up to down, like we folded a paper here, right? So if this were over here, if this was the paper, if you reflect it down, like we are doing over here, if you reflect it down, it would be x-axis symmetry. Since the horizontal line lies over here, the vertical line lies over here. So if it was the y-axis, it would be over here, and since it's x-axis, you fold it downward. So you see, if I say you fold it up and down, you think that you should know that I'm talking about x-axis symmetry. But when I say left to right, from left to right, or from right to left, it's y-axis. Or from up to down, or down to up, it's x-axis. It's a little concept that you should remember in your whenever you are solving an equation. We'll talk about the equations later on, but if you are trying to solve some equations, you should remember that, because when I reach the equation part, I'm not going to teach you what I have teach you again and again. Okay, so you guys better watch this video. I hope you are taking notes right now. So if this was, let's take an arbitrary point. If this kid was standing over here, x and y. Now I'm not going to repeat why is it positive and stuff, because I know that you guys do know that. So if this was some value of x and some value of y, and we reflect it over here, this kid would lie over here. And the x would remain positive, but what would change is negative y. So you see, if there is some value of x and some value of y, if it was reflected on x-axis, it would become some value of x and some value of y. So this is x-axis symmetry. Now, there's not only two symmetries, x and y. Okay, there's one more symmetry that you haven't learned or you haven't even pondered about. Well, I'm going to teach you. You don't even have to worry. After this video or any video you watch of me, I hope that I will make the concepts clear to you. You see, my goal is to make your guys' concept clear and get you pass all the tests with A+ or A, the highest grade you can ever have. So this type of symmetry is called symmetry from origin. Symmetry from origin. Now, as you guys know that origin is where y-axis and x-axis intersect at 90 degrees, okay? It's perpendicular. You see, if this was y-axis and this was x-axis, if this were to intersect, the origin would be right here, you see. You can make a graph like that, and you should know that because if you have watched my previous videos. Okay, but if you haven't watched my previous video and you like the way I teach, please go back and watch my previous videos, because if you start watching the videos from right here, it wouldn't be helpful at all, because all you are doing is wasting your time, because I'm not going to repeat the things that I've told you again and again, because I think you guys know it. Only for those guys who are completely watching my videos from the 1.1 rectangular coordinates and to this coordinates, and then later on in other videos that I'm doing. Okay, so reflection symmetry from origin will look something like this. If this were origin, you see, the reflection will look something like, hold on, that doesn't look alright. I never said I was an artist. Especially it's hard to draw on the whiteboard. Okay. See, I hope this is perfect, and this is all I hope. Okay. You see, if you were to now, I know I was saying something before, I just stopped, because I want you guys to understand, if this were flipped over here, it would be symmetry from origin, okay? That would be y is equal to x. Okay, but I'm going to teach you why is it y is equal to x. Okay, so if you were to suppose this was a tail of a dog, okay, a tail of a dog. If you were to take this tail of a dog and place it reflected off y-axis, because you're going from left to right, so you do it would look something like this. The tail isn't that clear, but see, if you were to take the arbitrary point here, like I told you, it would be some value of x and some value of y, and then here it would be negative x and some value of y, and then you reflect it back, it would look like this. You see, from now don't look at this. Now that we have reflected from y-axis, I want you guys to reflect it one more the final time from quadrant 2 to quadrant 3. Okay, only the final time. So if you were to reflect this dog's tail into the quadrant 3, and here's the dog tail, if you were to take this arbitrary point, and I hope this is the arbitrary point that is placed over here, so you get negative x to the negative y. So symmetry of origin is all combining x-axis and y-axis, two concepts all together, because the thing that I've learned you previously is x and y and negative y and negative x and y, and then in quadrant 3 it's negative x and negative y. Okay, so you can also test the symmetries, that if there were a symmetry, you can always like draw these figures and randomly say yes, it's a symmetry, because some concept might look little bit similar, but it's off from a little bit. Okay, so there is always a test for this kind of symmetries. Let me tell you one type of symmetry. Now for y-axis symmetry, let's go back from where we started from. Y-axis symmetry. Let me erase this too. I hope you guys have written this in your note as well, because there's some definitions that I'm going to write and there's some definitions I'm going to speak while I'm solving it. So test 4. Now what are we testing for? The thing that we started from, which is y-axis. Now here I'm going to write an equation, but it will be a lot different from the equation you would get it from your test or from any textbooks. But the thing here is, guys, is you should know how to solve a problem. If you know how to solve a problem, there should be no difficult on which problem that someone puts in your face. Okay? If teacher says you look smart, but let me ask you this question to test your skills. Okay? Some teachers might do that. Like in my school, there are some teachers who might do that. Okay? So if you know how to solve it, it should be no difficult on how to solve. Oh, how do you do that equation? Well, Karan didn't do it, so I don't know how to do this one. I only know one equation. Well, I'm going to teach you what I'm doing here. Okay? So better listen up. Okay? So if you were to have y is equal to x squared minus 4. Now is the point which is located here. Okay, if you see, if you were to have y-axis symmetry, the point here is x and y, and the point here is negative x and y. You see how this x is negative over here? That is what we do over here. So the y remains the same, positive, so we do negative x squared minus 4. Because after all, x is the only one that changes its sign, right? So what if let me ask you guys a question. What if you had negative 2 squared? What would it be? Well, you might say, no, it's 4. Well, guess what? Negative x squared is x squared e. So, let me write it as in other marker. So the concepts are clear, you see. Y is equal to x squared minus 4. Well, guess what? This equation right here is similar to this. So we can prove that the equation that we have been given is equal to the point that we have taken on the graph. Thus, this is a symmetry of y-axis. You see, these guys are identical. These guys are twins. You may think that these guys are twins. Okay? Now let's use this equation in x-axis symmetry. Okay? So now if you were have to take this graph into x-axis, you know that it's going to fold from up and down. So if you were to take this arbitrary point here, and this is, we know by looking at the graph, we know it's not symmetry. Okay? So if you were to take this graph, I hope this is the arbitrary point, that's the best I can do. So the x would remain the same, only the y wouldn't. Okay, now we have this equation. Now we don't know that if they are identical or not. So you would have negative x, there is no change in sign of y, I mean x, so you have negative y x squared minus 4. Now if you divide negative 1 by both sides, you would get x equals negative x squared. Negative signs cancels out, so it's plus 4. Now if you see this graph, let me just make you guys clear if you can't see it. It's plus 4. So negative x squared, like I told you before, negative 2 squared is always 2. So let's write that as x squared. Well, it turns out that minus and positive isn't similar, because there's plus 4 is where you go this side, and negative sign is negative 4 is where you go this side. So you see it's opposite, so it's not similar. See? I hope you're getting this. So these kids are not twins. Whoops. It was a mistake by some person that thought they were twins, but it turned out that they're not twins. They might look similar, but they are not twins. This is the best way you can figure out. Now let's try origin. Now the equation we have used was y equals x squared minus 3. X actually 4. Okay, so now how would you do origin? Now if you were to fold this graph into origin, it would be here, right? And origin requires two methods, like I told you. This one comes here and one more symmetry up from over here. So negative x remains the same, but y goes into negative y. So you see, everything changes. Like if x and y were positive over here, it would both change its sign to negative x and negative y. So we have to change this guy's signs. Negative y is equal to negative x squared minus 4. So negative y we divide by negative 1 on every side. So we would have y is equal to x squared, which is similar to this one, but the problem is we don't have minus here. We have plus 4 here. So you see, there was another mistake in identifying the child. Now I'm taking the child as an example here, are not identical. This is like error. This is not identical. Okay. So I hope whatever I taught you guys, it's the ideas taken from the y-axis, x-axis, the origin symmetry. So to summarize what I teach is, when you have a graph, hold on. If you were to have a graph, I'm going to teach you very quickly, as soon as I can, because I'm running out of time here. So, if you were to have this graph, okay, this graph, and you have some kind of symmetry, let's say, and I hope this is a symmetry. You might say this is symmetry, origin symmetry, symmetry from origin, okay? So what will you do to find that out? If you have an arbitrary point here, which is x and y, you would have arbitrary point here, so representing at negative x and negative y. Let me write it here. Oh, negative x and negative y. So you see, it's flipping the signs. But if you had, this is original symmetry, okay? So if you have x and y, and it would go to negative x and negative y, you know it's origin symmetry. Now, I'm writing black marker. Black is the origin symmetry. You guys have to remember. Now, just only for this example, not for the later on, okay? Because then I would remember what I said. So x and y, turns out that negative x and it's flipping the sign. If you take this dog tail over here, it would look something like this. Now if you take this arbitrary point over here, it would turn out that it's negative x and y, some value of y. So all we did here is, if you had x and y to start with, and you would land up to negative x and y, you would have x-axis symmetry. Okay, but what if you have this is my bad, this is y-axis symmetry. But what about x-axis? Now the blue marker over here represents the y-axis. Let me just write y. This is the origin, so I'm writing O. And now I'm going to do x-axis symmetry. So if you were to have, oh god. So if, suppose this was some arbitrary point right here, and I take arbitrary point over here, this would look something like it has the same value of x, only the y value changes. So if you have x and y to start with, and you land up to same value of y and negative y, change in y, you would have x-axis. So this 3 symmetries, I hope this is clear to you guys, and if you guys like my explanation, please go ahead, take time to subscribe so you can get notifications when I upload more videos, or you can like my video so I can know that I'm doing my best to make the concept easier. Thank you.